Oh, we are seeing tools develop right now. We have seen great progress in very large-scale operations. I think what we will continue to see is more broader adoption, not only of what is called FRP in the browser, for example, but realizing that distribution for failure handling, resilience, and so on, and all the infrastructure behind, that will still require some shift to be fully in the mainstream. The best way for starting to learn actors in general is to consider them to be like people. If you have a problem and you want to solve it using actors, you need to picture a group of people on infinite supply if you need, and you need to figure out how they should organize themselves, who should talk with whom to solve the task at hand. And then you sketch down these information flows, you sketch down the conversation patterns, and that defines the structure of your implementation of your application. And once you have done that, it becomes rather simple to then figure out what each participant shall do. And only at that point do you really need to dive into the syntax. It's not overly complex, but at that point it should be really obvious what you should do. The first day, I very much enjoyed Heidi's talk about consensus. I also enjoyed Sergei's keynote. But there were many great presentations, so it has been a very, very high level of presentation so far. I'm looking forward to Amira's talk about IoT, so let's see what she has to say. The theoretical results are important for knowing the limits. For example, impossibility results can tell you something that you cannot expect of your system if you need, for example, perfect consistency. But that's not usually what you really need in a production system, so you can tolerate some failures, some errors, some inconsistencies, and what I think we will see is more of a confluence of trying to bring down the cost of consistency, or to offer a kind of consistency in your distributed systems that is not as costly, but which models more closely what we actually need. There's a lot of research going into causality tracking, for example, for that reason, because that happens to coincide quite well with how we humans interact and how we think, if something can be caused by another or not. And there can be inconsistencies if there is no causal relationship. That will be an interesting thing to watch develop. Big data is an interesting term. I've heard it used for so many things. It started out as really being big in the sense that it cannot possibly fit in one machine. I have applied that at CERN way before the term was coined, but now it basically means everything that uses large amounts of sensor data or things like that. So it's become much broader, the term. I think the most interesting aspect to consider here is that the data are now in motion. That is the thing that we see changing. That's the qualitative switch. It has nothing to do with the size of the data necessarily. You could have huge amounts of data rolling through your system, or you could have a small trickling stream of updates that you need to deal with in real time. But I think we're moving away from static, schema-based data in tables, rows, and columns, more to data streams and how you express the information flows in your systems. The specification has not really seen any need for updates so far on the fundamentals. There were documentation, specification clarifications, but I think that was a very successful engineer-based, not JEP or anything committee-based effort that was successful due to that reason. And it's been picked up by quite a few implementers. Now it's entering Java 9 as well. So that is a pretty good way to get data from A to B. And that's all it was meant to do. And if we can standardize on that, then that is the minimum basis we need for modeling data streams. But of course, the real work is in making useful implementations that you can transform these streams and react to things that happen and so on. And there we see a multitude of implementations springing up just as we hoped. There is not only Akka streams, of course, RxJava and all the others. It will be very interesting to have database drivers. Maybe I'm still hoping for a JDBC2 kind of thing that is stream-based. Let's see where that happens.